This is how you solve simultaneous equations. First you write out the equation in full, then you number both equations A and B. Next you want to remove one of the variables. Let's remove the x variable. Multiply equation B by the coefficient of x for equation A, like this. Then take equation B and minus equation A, so the x variable disappears. Next, to find the y variable, divide 5y into 15 and you will see that y is equal to 3. You then substitute 3 into y into equation A like this. Then rearrange the equation to 11 minus 9 equals 2x. Then divide 2x by 2 and get x equals 1. Then substitute both your answer for x and your answer for y into both equations A and B, like this, to see if your maths is correct. 2 plus 9 equals 11. 1 plus 12 equals 13. Done. Now we move on to 3 by 3 simultaneous equations. Once again you write out the equation in full, then you number all 3 equations 1, 2 and 3. Next you want to remove one of the variables. Let's remove the x variable. Multiply equation 2 by the coefficient of x for equation 1, like this. Make this equation 4. Now minus this new equation from equation 1. This cancels out the x variable and you are now left with equation 5. Next you want to multiply equation 2 by the coefficient of x for equation 3 to make equation 6. Then you want to minus equation 6 from equation 3 to make equation 7. Now that we have removed the x variables from 2 equations, we can work out what the z variable is. Take equation 5 and minus equation 7 from it. This gives a value for z. Now we can work out what the y variable is. Take equation 7 and substitute the z variable in. Then you want to minus the value of z from both sides of the equation to leave a 3y equals 381. You then divide this value by the coefficient of y and you get y equals 127. Then you rewrite equation 2 substituting both the y and z variables. Then sum the total for y and z and remove this value from both sides of the equation and work out that x equals 184. X equals 184, y equals 127, z equals 79. Then substitute these numbers into equation 1, 2, and 3 to see if your maths is correct. If your numbers add up correctly, congratulations, you can now do 3 by 3 simultaneous equations. Now how to solve simultaneous equations when you only have the solution 30, 30, and 20. You must find 3 equations with 3 variables each. For example, 3x plus 2y plus 7z equals 2x plus 6y plus 9z equals x plus y plus z equals. In the solution 30, 30, 20, the first column represents an x value, the second a y value, and the third a z value. Plug these values into the 3 equations and you will have 3 equations that give the solution 30, 30, 20 by multiplying the solution by the coefficients you just created. This will give you 3x plus 2y plus 7z equals 290, which is equal to 90 plus 60 plus 140 equals 290. 2x plus 6y plus 9z equals 420, which is equal to 60 plus 180 plus 180 equals 420. X plus y plus z equals 80, which is equal to 30 plus 30 plus 20 equals 80. Drawn on a graph with 3 axes, each of these equations represents one of 3 planes. The solution 30, 30, 20 represents the point on the graph where all 3 planes intersect. In real terms, this might represent the point in space where 3 surfaces come together. For example, where 2 walls meet the ceiling in a room.